Hello, everyone. We are the ITC LEED Metering Senior Design Team. I'm here with the team -1, but our sponsors are Gordy Halt, John Bonk, and Jason Cooperman from ITC Holdings, and our advisor is Dr. Lukowski. To give you an idea of what our project is, ITC is looking to get their main office LEED certified. So LEED certification is a measure of how environmentally friendly and efficient your building is. And so in order to be able to report data for that, they need a metering system that can measure their water, gas, and electrical consumption. So we're not getting them LEED certified, but we are getting them the data that will show that they are LEED certified. So our metering system needs to be able to measure multiple different sources. So two main water sources, that would be the well and city water, the gas, and then two different electrical sources, so the grid and then the on-site solar field that they have. So our metering system must include a data integration system, and eventually we will need to meter the air quality for future projections of LEED requirements, and then we were given a budget of $60,000.
So we've come up with two options. The main differences for these two options come in the electrical metering configuration. So our first option uses a more detailed meter placement that allows for floor level analysis and will hopefully allow for prediction of faults. So we have electric meters placed on the first, second, third, and fourth floor. And so this placement will allow us to meter all 7 floors. And we're going to use multi-point meters to cut down on costs and make the system overall more efficient. And we will have between 2 and 8 gas meters and a single water meter to measure the system. And the second option will be meeting the minimum LEED criteria with only meters placed on floors 1 and 2 on major switchboards and only using multi-point meters. So we'll lose some granularity there.
So here you can see the overall one line of the first solution. And here's a more zoomed in version of one of the panels. You can see the multi-point meter that has 6 different loads going to it. And here on the left, you can see an example of one of the loads that has 3 current transformers on it being fed into the multi-point meter seen on the right.
So for recommendations with ITC going forward to install and purchase the system, we want them to use their current building management system, as it will be able to handle and manage all of the data properly, and purchase the meters through a single distributor, as that would make it the most convenient, or the lowest cost option, which would be a combination of different distributors. And they will need to install the meters on a day when people are out of the office, as electricity, water, and gas will need to be shut off to install those meters.
And so a cost analysis was also done where there was a spreadsheet that was created to look at the number of each type of meter multiplied by the unit price quoted by different distributors. Then we gave a total price from specific distributors. It gives ITC the overall price if they were to go with one distributor, but it also shows pricing at other places where they could pick the cheapest price if they would like to. Overall, our group would like to thank our sponsors, Gordy Halt, John Bonk, and Jason Cooperman, our advisor, Dr. Lukowski, our former sponsor, Dave Smith, our Leviton contacts, Kira Schmidt and Bob Kokovich, ITC BMS contact, Don Rodriguez, our EE professors at our update presentations, and some MTU LEED contacts, Jacob Guter and Larry Hermanson.